R is rho or PL over A. Now you know P is the specific resistance, you see. So if we write that part, specific resistance P is 0,0159. Now look at this though, they say micro ohm. When they say micro, I say divide by what? By a million. 1, 2, 3, 4, 5, 6. Then it will be ohm meter. Let's get that. Let's divide that by a million. Those are the things that you need to be very sensitive of. 0,0159. All right, and then I divide by million. 1, 2, 3, 4, 5, 6 equal to 1,59 times 10 to the power negative 8. 10 to the power negative 8. Just do that. And then look at this. The resistance of a silver conductor is what? 10 ohms. The resistance, already they gave us resistance here because we're always looking for resistance. So R is equal to what? 10 ohms. And then calculate the length. Oh, they want the length, which is, I don't know the length. Of course, it will be in meters. Hello once again, our most valued student. My name is Confident and welcome to the ultimate guide for your industrial electronics at 13-day intervention. You just need 13 days, at least, actually I'll say at most 1 hour a day. Just 13 days, 1 hour, and you'll cover everything on industrial electronics. You need to watch these videos from the beginning until the end, and I guarantee you, you'll never struggle in that exam. So this is to prepare you for your final exams, and it's everything that you need to know. Now, let's come to this topic. Is an intervention plan, which is divided into 13 different videos. Already, I've covered video 1, basic atomic theory. Number 2, conductors and insulators, and in this lesson, we are looking at resistors. So now, just to be clear already, when it comes to resistors, I have covered part of resistors in the sense that resistors are also linked with this topic called direct current theory. See this one. So this topic will also involve resistors, but I just gave you a sneak peek of the resistors as we're beginning this lesson. So let's dive into this lesson without wasting time. Now, the first part which says here, look at this 8 marks. How can you ensure that you grab these 8 marks? It says a copper conductor has a length of 150 meters and a diameter of 2.5 millimeters. Determine the resistance of this conductor if it has a resistivity of 0,0177 micro-ohm meter. Now, what do you need to do first? You need to identify the formulas that you will use in these questions. And I just want to show you 2 formulas which you must be very comfortable with, and you must never ever have trouble with these 2 formulas. Whenever you're going to be dealing with this section of resistors, I will encourage you get comfortable with these 2 formulas. All right. Now, the first one, it will involve temperature. Whenever you're dealing with the resistance and you see temperature, just know that it is the first formula. The second formula will start talking about the length and the area or the diameter. So the moment they mention things about diameter, just know that it's this formula which has got A. And the moment they mention about the length, it is this formula which has got A. So also, what I want to remind you is about this A, which is the area. There are 2 ways of finding area. Area is, I prefer this formula, pi r squared. This is the formula I always prefer, but we are also going to use this other formula, pi d squared over 4. All right, so it's up to you how you're going to do it, but I'll show you both formulas so that you can choose which one you want to do. So let's start here. It says a copper conductor has a length of 150 meters. So remember our formula, when it has got length, which one do we take? R is equal to PL over A. So that's what I'm going to write here to say our resistance R is equal to PL over A. So now we need to identify which is which. First of all, they already told us length is 150. So which means L is equal to 150 meters. Now your units must always be in meters. The SI unit of length is meters. So the units are fine there. Look at the next one now. Diameter of 2,5 millimeters. Now we have a problem there. 2,5 millimeters, which means we have to convert it to meters. Now, you know how you convert a millimeter to meters. What do? You multiply, which is times, you multiply millimeters times 10 to the power negative 3. Or you say millimeters, you divide them by 1,000. It's up to you. Sometimes I prefer dividing by 1,000. So 2,5, you are going to say, what is that? The diameter, D in this case, its diameter will be equal to 2,5 divided by 1,000. So millimeters, just divide by 1,000, it will convert to meters. So what are you going to have as the answer there? Your calculator will come handy, and let me see what it is going to give me. So this is 2,5 divided by 1,000 equal to, press SD, which is 2,5 times 10 to the power negative 3. See, so it's 2,5 times 10 to the power negative 3. But what do you have now? It's meters. Now they say determine the resistance of this conductor if it has a resistivity, which is your P is your resistivity of what? Of what? It's called rho. Usually they call it rho of 0, that. So my P there, let me use that to say my P is equal to 0,0177. Now another word is different there, micro ohm meter. When you see the word micro, we have a problem also. Millimeter, you multiply by 10 to the power 3. What about micro? If you see micro, you multiply by 10 to the power negative 6. Or you take micro, you divide by 1 million. So 1, 2, 3, 4, 5, 6. So just remember this. If it's micro, you multiply by 10 to the power negative 6, or you divide by a million. So which means here my P was going to be 0,0177. I can divide by 1 million like this. It will convert it to ohm meter, not micro. You don't work with micro, you don't work with millimeters. So I'm just taking my time here so that you can understand how this question, you don't lose any marks at all. So 1, 2, 3, 4, 5, 6. I hope I did right there. That's a million equal to, this is 1,77 times 10 to the power negative 8 times 10 to the power negative 8. But now this is ohm meter. Alright, so when you have done this, the question is now determine the resistance of this conductor. So the resistance is this formula. R stands for resistance. But how do you write it? Look at this. You're going to say, let me take this formula a little bit here. So don't worry about this. So we're going to say R is equal to PL. So R here is equal to P. We have our P, which is what? 1,77 times 10 to the power negative 8. So it's 1,77 times 10 to the power negative 8 times, that P means there is a times. What is our L? Our L is the length, and you remember the length there, what was the length? Is 150 meters. So you multiply times 150. Now divided by A. A is the area, but they never gave you the area, they gave you the diameter. So let me put again a little bit of foundation. This is my circle, this is my center, and they gave me the diameter. Remember what is the diameter? From that end to this end. So from the end, which is A, you pass through that center C to the other end, which is B. That long line AB is called the what? The diameter. Now the problem with the formulas is that they don't give you anything that links the length to the diameter. So it is now your mathematics that comes in handy here to say, I will encourage you this one. The area of a circle is pi r squared. It's one of the easier one to master, pi r squared. But now the problem is that you are given the diameter, not the radius. But what is the radius? The radius is half of the diameter. So half of that is our radius. So if I take that radius and I take another radius here, so I've got a radius and I've got another radius here. When you add radius plus radius gives you what? It gives me the diameter. So now the question is, since they gave me the diameter of what? Of 2,5. It means I can take this diameter, and if I divide by 2, I will get the radius. So take the diameter, divide by 2, you get the radius. So what was our diameter? It was 2,5. You divide by 2, but remember we converted these. It became what? 2,5 times 10 to the power negative 3. So if I say 2,5 times 10 to the power negative 3, divide by 2, it will be my radius. And now what will be my radius? I need now to take this thing a little bit down again so that I don't mix things here. So let me take it down. So it is going to be what? The radius here, if I divide, so that is the formula I prefer at the beginning that you can use. If you want to use the one for the diameter, we're going to use the same. The answer won't change. 2,5 times 10 to the power negative 3 over 2, which is equal to what? 1,25 times 10 to the power negative 3. So this is what you have as your radius. So now you can come here and say, what is my area now? My area is equal to pi times r. You have your r now. You see that? Which is 1,25 times 10 to the power negative 3. Because of this long number, put a bracket there and then you put squared. This is your A. So what you do now, you come to this formula. Let me do this. You come to this formula. Remember, this formula said divided by A, but you have your A there. So you can come here on this formula and say divided by what? By pi times bracket 1,25 times 10 to the power negative 3, and then you square. You see that? So that is the resistance there. So the resistance here will become, if you want to find your answer here, you can find your answer. Use a calculator here, still fine, but you can just go straight from here. So let me use the calculator once. Look how I'm going to use it. It's 1,77 times 10 to the power of negative 8 times 150 divided by pi. Actually, yes, it's alpha pi. No, it's shift pi times bracket 1,25. You see what I'm doing now? Times 10 to the power of negative 3. Then close the bracket, and then you've got what? You have got squared. Then equal to, they need to give me 0,5 to 3 decimal places, which is most secure. 0,5408. If you want your calculator to do for you 3 decimal places, you say shift setup, you go to number 6, which is fixed. 3 decimal places, you press 3. There it is, 0,541, which is the answer there, 0,541. Now resistance is measured in ohms. So that's the answer, guys. I was taking my bit of time here, but that's how you do it. If you wanted to do it the other way around, which is using the what? The diameter. I'm gonna open a window there. Remember I said the diameter, you can use the formula for the diameter and the area, whereby you're going to say area is equal to pi d squared over 4. If you can master this formula, this is also good. And then you take your pi times your d squared. Remember, they told us the diameter. It was what? 2,5 times 10 to the power negative 3. Now you don't have to change it. It's just 2,5 times 10 to the power negative 3. This one you don't divide it. Remember, it's squared. You put your square, divide by 4. This is what you will put here where there is that r. Or you can first find your answer here. Let's do that and say fraction pi times, and then you've got 2,5 times 10 to the power of negative 3, and then it's squared, and then you divide that by 4. then you get this answer, which is 4,9087. It's better to write as many digits as you can so that you don't lose a lot of rounding off, which is 4,9087 times 10 to the power negative 6. 4,9087 times 10 to the power negative 6. This is what? Your area. Then you take that answer, you remember your resistance. What was it? We said R was equal to 1,77 times 10 to the power negative 8 times 150 divided by area. This is the area there, which was the answer that we got there, area, which is what? 4,9087 times 10 to the power negative 6. Your calculator will do your most of the work here, which is 1,77 times 10 to the power negative 8, power of negative 8 times 150, and then you divide that by 4,9087 times 10 to the power of negative 6, right, equal to why is it giving me a 0 here? Okay, equal to, then shift setup, let me say 8 here, and then 1. I don't want to round it off. This is 1, okay, sorry about this, I made an error there. Supposed to remove this, it's too much big number there. Play forward, it's times 150. It was like an exponent there. Alright, so there it is, 0,54087. Shift setup, 6 is fixed to 3 decimal places, 0,541. 0,541 ohms. It's up to you guys, which one do you prefer? If you're preferring this one, use it, but for the remainder of this lesson, I'll just be using pi r squared so that you can get used to it. Alright, let's move on to the next question, but now I'll try to be a bit faster. Alright, says a conductor has a resistance of what? 5 ohms at a temperature of 0 degrees. Now, pay attention. They are mentioning the word temperature. If they are mentioning temperature, you must know is the other formula. Remember I told you about these two formulas? There it is. When they mention about length and area, you know what to use. But look, there is our T for the temperature. So calculate the resistance if the temperature increases to 60 degrees Celsius and the conductor has a coefficient of that. So let's take that formula in. It says RT is R0, then I'll explain all that, 1 plus alpha 0T. So let me write it slowly down there. It says RT is equal to R0 bracket 1 plus alpha 0T. Am I right? So RT is called R0 1 plus alpha 0T. Close the bracket. So this is what you have. Now what information are they giving us that we already have here? So the first one is a conductor has a resistance of what? 5 ohms at a temperature of 0. So this is more like, if you see temperature of 0, it's more like at the beginning and is linked to R0. More of at the beginning, or you can actually tell yourself to say R at 0 degrees Celsius. So which means in here they gave us our R0, the resistance at temperature 0, which is 5 ohms. So far so good. Just remember that when you see 0 temperature, that is R0. If they tell you the resistance, calculate the resistance. You see, they need still the resistance, which is now at a T, R at this temperature, which is here at that T. Now, if the temperature increases to what? 60 degrees. So now, which means your small t is 60 degrees Celsius. The coefficient, that is your alpha at 0 there, which is equal to 0,0059. Already it's ohm per degree, so the units are fine. Ohm per degree Celsius. So how do you apply this formula? It's simple. You just applied RT is equal to R0, which is 5 bracket 1 plus 0,0059 times 60. And then you write your final answer, and don't forget you're calculating resistance. And what is the units of resistance? It is in ohms. So it's 1 plus 0,1259 times 60. See, then you have to get 6,77. So you've got 6,77 ohms. It makes sense if you remember the properties of resistance. We're saying as the temperature increases from 0 to 60, you see, the resistance also increased from 5 ohms to 6,77 ohms. Next question. Alright, let's look at the next question here. The next question says the resistance of a silver conductor is what? 10 ohms. Calculate the length of the conductor if the cross-sectional area is that, and the specific resistance of silver is this. What are the key words? Number one, they are saying calculate the length. The moment they say length, you know what they mean. You have to link it to that formula. R is PL over A. So we write that formula first of all. R is rho or PL over A. Now you know P is the specific resistance, you see. So if we write that part, specific resistance P is 0,0159. Now look at this though, they say micro ohm. When they say micro, I say divide by what? By a million. 1, 2, 3, 4, 5, 6. Then it will be ohm meter. Let's get that. Let's divide that by a million. Those are the things that you need to be very sensitive of. 0,0159. Alright. And then I divide by million. 1, 2, 3, 4, 5, 6. Equal to 1,59 times 10 to the power negative 8. 10 to the power negative 8. Just do that. And then look at this. The resistance of a silver conductor is what? 10 ohms. The resistance, already they gave us resistance here because we're always looking for resistance. So R is equal to what? 10 ohms. And then calculate the length. Oh, they want the length, which is, I don't know the length. Of course it will be in meters. Now they gave me also the cross-sectional area. The good part is already I've got my A for area. What is my area? There it is 0,40. 1, 2, 3, 4, and then 1, 0. You see, units are in meter squared. And then I need you to be careful now how you're going to apply this formula. Look at this, because if you're not careful, you might lose your marks. Look at this now. They want you to find the length. Look where the length is. It's mixed up with a lot of things. So how do I find the length? There are two steps that you must do first before you can start putting these values. Don't just be quick to put these values. First, you make L the subject. Here is the subject of formula. Remember mathematics now. How do I make L the subject of formula? Now, since I'm interested in L, the first thing I need to do is to multiply by this A here, and you multiply by A on the other side, so that the A at the bottom goes. Then you have got A times R is equal to PL. So you see, we are still having our L there. Are you with me? Then last step is, since P is multiplying L, the opposite of multiplication is division. Divide by what? Divide by P, divide by P. Then there is L remaining alone. So what does it say? It says take A, multiply by R, divide by P, which is equal to our length. Then you can apply now the values to say what is A. They told us is 0,40 and 10. So I'll write here and say 0,1, 2, 3, 4 and 10 times what is the resistance? It was 10 ohms. Alright, divided by P, or our rho, the resistivity or the specific resistance, which is 1,59 times 10 to the power negative 8. 1,59 times 10 to the power negative 8. Then it is going to give us the length. Don't forget that particular length will be already in meters. So what you do is 0,1, 2, 3, 4, and 10 times 10 divided by 1,59 times 10 to the power of negative 8. Alright, equal to, there it is, 6,289.308. 6289.308. 6289.308, I think, meters is the length of this conductor. If they say what is kilometers of this, remember it's 6,000 already, you divide by 1,000, it is 6,289 kilometers. Remember, now you're going to pick a length, but it's better for you, I'll say just leave it like that. Don't confuse yourself further, leave it like that in meters, they'll give you a full answer. Alright, so guys, this is how you approach such questions, and I don't want you to struggle with such questions. Alright, now we're going to do more. There's more coming. Just stay tuned. Remember, watch this video until the end, because the questions, the way they ask them, they've got different ways of asking them. So stay tuned until the end so that you can see how they change about, and next time they bring a question that looks similar, you are able to get it straight away. Look at 3.4. It says, name 4 factors that influence the resistance of a conductor. How many factors? There are 4 factors. What do they affect? The resistance of a conductor. Now, I will encourage you to use the same formula here that we used. Where is the formula? RPL over A. Or take you back to this formula, RPL over A. That's where you'll remember all of the factors there. So let me write that formula to say R is equal to rho L over A. Now the next thing to remind yourself is, what does it mean? This means length, this means area, and then this means resistivity, and this R means resistance. When you can know the labeling of these, now you can know the 4 factors. Let's start with the first one. The first one, the factors that affect the resistance or influence the resistance of a conductor, number 1 is the length of conductor. Alright. Number 2, so this is number 1. Number 2, you can see, is the what? Is the area, cross-sectional area. That's how you can write it like this. Cross-sectional area. See, I'm getting them from the same formula there. Number 3, what is number 3? Number 3, you see, I say the resistivity, which means the material type here. Material type. So resistivity is about the type of the material. And number 4, which is not there, the last one is temperature. Alright, always remember these factors. They are very important and they always ask them. And then look at the second question. It says, explain how each factor in question 1 influence the resistance. Now they want you to say, of these factors that they're giving us, how do they affect the resistance? You understand? They want you to explain now how each factor affects. You don't have to struggle. Look at this. You see the length is on top, then you must know the longer. You just say the greater the length. I think the greater is the better word. The longer, I don't feel comfortable. Just say the greater the length, and then what? The higher the resistance. The resistance. So that's what it does. When the length increases, the resistance increases. Or you are allowed to say here, the length is directly proportional. Directly proportional. You know that word, directly proportional. It means when one increases, the other increases. To resistance. The next one, cross-sectional area. Look, it's at the bottom. See, resistance on top, cross-sectional area is at the bottom. So is the one is the inverse of the other. So what you're going to say with the cross-sectional area, the bigger the area, the smaller the resistance. You do the opposite. or you can say the area, the cross-sectional area is inversely proportional to the resistance. And then the type of material, you're going to say here on the type of material, some materials have more free electrons than others. So that is that. Remember, that is now comes to insulators, conductors, semiconductors. And then the temperature here, what I'm gonna say, the higher the temperature, the higher the temperature, the higher the resistance. So temperature is directly proportional in this case. The higher the temperature, the higher the resistance. Guys, this is what they needed. Now, if you remind yourself of this, pause this video and redo this again and again. This is 8 marks. Look at the mark allocation here. 8 marks, and you don't want to use the 8 marks. Number 1, you must know the factors. Number 2, you must know how they affect the resistance. Are you with me? So don't forget the factors, the length of the conductor, the cross-sectional area, the type of the material, as well as temperature. Temperature, length, all these, when they increase, the resistance also increases. Only one that differs is the cross-sectional area. When the cross-sectional area, meaning when the conductor is thicker, that is when it's thick, the resistance is smaller. Okay, when it's thin, the resistance is higher. So, but you just simply say the cross-sectional area, the bigger the area, the smaller the resistance. The type of material, you can just say some materials have more free electrons than others, meaning those type of material will have less resistance. All right, so now from there, what I want to do, guys, just for a second, pay attention. I won't take much of your time. This video, it has been sponsored by Ekurhuleni Technical College. They are the ones which made this video to come to make it possible for this video. So as I say, guys, we bring these videos for you at no cost to you, but behind the scenes there's some cost involved, and Ekurhuleni Technical College has been good in sponsoring this video. And what they do is just to give you a sneak peek of what Ekurhuleni Technical College does in Krugersdorp. It offers engineering studies N1 to N6 with installation rules. Some of you are doing installation rules, can check that. And this is their website, as you can see, and their contact details, but they are very, very specific. They offer distance learning, so this is what they do, offer distance learning or correspondence, and you can check their courses. And as you can see, this is installation rules exam in progress here. If you're interested in that, again, there is their website, as well as I said to you, with distance learning, you can check what they support you with, especially these videos that I'm giving you. We make them available to our students who are going to be registered under Ekurhuleni Technical College, as we are in partnership with them. All right, so if you are interested, just check their website. It can come handy to you. Now let's move on to the next lesson. Come here to say. Now, what I will encourage you to do now, some of these questions are now repeating. It's repetition, repetition, repetition. If you want to benefit more, pause the video, attempt the question. After attempting the question, what you need to do then is for you to check your answer against mine. All right, so let's do this question. It says a copper conductor has a resistance of 60 ohms at a temperature of 40 degrees. Right, the moment they mention temperature, always remember my formula must be the one linking temperature in it. So let's come back to our formulas. They just mentioned temperature. It means I might use this formula here. Why? Because it has temperature, but that's not the end. Let's continue. Determine the resistance of this conductor at 0 degrees. Be careful now. If the temperature coefficient taken is that. So the way I say it, all the units are fine, but now look what they did. They say a conductor has a resistance of what? 60 ohms at a higher temperature at 40. So be careful there. 60 ohms at 40, but they want you to find the temperature at 0 degrees. So remember, when you see 0 degrees, this links your R, 0. So what is the formula? It says R is equal to R0 1 plus alpha t. Where is it? I'm taking it from here. So now already they told you, that's where now they usually trick you. They gave you 60 degrees. Let's put our units here. They gave us 60 degrees. Which one is that? This is our temperature, T. So T at 60 is what? Actually it's T at 40, not 60 degrees. T at 40 is what? 60 ohms. You see the resistance. What am I writing here? The temperature, actually, let me just say temperature is what? 40 degrees. And then the resistance at 40, that's what I wanted to say, is 60 ohms. So now you must see that this formula now is actually giving you that R. Your aim is to find R0, because they are saying determine the resistance at 0 degrees Celsius, meaning the beginning. Are you with me? So if we can do that, what I have is okay, they gave us the coefficient there, which is alpha is 0,00428. You see that? We can now apply the formula and say, look at this now. How best can you use this formula? If they are interested, let me take it further here. If they are interested in that R, let me repeat again something to make you see it. They are interested in that. What you need to do first is to get rid of this guy. So what you do, you divide. You see, R0 is multiplying. It's multiplying. So first of all, before you put any numbers, divide both sides plus by that in the bracket. This bracket, alpha t. Why? Because I don't want that bracket. But what is on the left, I must do on the right. So even here, you divide by, I can just pull it a little bit far now, like this. Alright, and at the same time, I just want this guy at the center here. So it's R, and then it's what you do on the left, you do on the right. Remember, that's it. So now when you try now to find, look at it, I have got R0 remaining here. See that? Which is R all over 1 plus alpha t. At this stage, I can now substitute. What do I have? They told me the resistance is 60 R, resistance of 60 ohms. So you put your 60 here over 1 plus your coefficient there, it's 0,00428. See that? And then times the temperature was what? 40. So remember, this is where this must give you R0 that is even smaller because the temperature was less. So don't expect to get a bigger answer here. It must be smaller when the temperature, remember, the lower the temperature, the smaller the resistance, or the lower the resistance. So 60 over 1. Oh, by the way, I forgot the brackets. The brackets are very important there, which is okay, but they were not important as such. So 0,00428 times 40 there. All right, I don't think the brackets didn't make any difference. There is 51,2295, which is 51,23. So 51,23. Remember, it's in ohms. This becomes my initial resistance. So that's the answer there. You can see it is smaller than the first, the one at 60 degrees. At 40 degrees, it was 60 ohms. Are you seeing that? So this is that. Now, look at the next one, guys. Because of my time, look, this was another 8 marks. I'm forced to end this lesson here because why? I just want to give you undivided attention. I have to make part 2 of this video, and in part 2 of this video, look at this. We'll still continue with 3.6. We will still continue with 3.7 here. As you can see, I've got 3.7. These are previous question papers. I'm just focusing on previous question papers. There is 3.8. We'll still continue, so that's why I want you to check the next lesson. Look, it goes to 3.9, you see, and then goes to 3.10. Now it continues. That's not the end. That's not the end. Now something is interesting with 3.11. 3.11 now deals with resistors, the ones in series and parallel. Just as I said, it's knowing how to calculate the total resistance. You see that? And then look at this again. 3.12, we're going to learn how to find the total resistance here. A very important diagram, 8 marks, just to calculate the total resistance. So I will encourage you, stay tuned. Check the part 2 of lesson on resistance. You need to know the second part. And again, do not forget, guys, as I mentioned, everything here we do is already now under the sponsorship at the moment of this industrial electronics. It is being sponsored by Ekurhuleni Technical College. They are the ones who are sponsoring this particular lesson of industrial electronics, the ultimate guide in your exam preparation, and you can check their details here. Why am I showing you these videos? Because they also offer N1 to N6 engineering studies. You might be interested in registering with them for distance learning mainly, and you can also get access to these videos. It's maths, it's science, and some of the these videos, but they will tell you more what they offer also. So this is them here. You can just check their details. But remember, all the questions that I'm bringing, if they are now repeating, pause the video. After pausing the video, work them out, then compare your answer against mine. We've come to the end of our lesson. Join me in the next lesson. Thank you.